I'm going to be doing an example that a student in our class asked me about from chapter 4, specifically Jackson, number 17, which is sort of like a capstone of the entire chapter. Um, I'm going to share my screen. Let's get to that example. It's chapter 4, number 17. Now, before I show you how to solve it or help you solve it, I should point out that there are many videos that I made in the list of videos associated with chapter 4 that explains the theory behind a lot of this material. But I'll do my best to explain from a practical point of view and just explain what's happening. So let's start with the data. We basically trying to predict the price of BMW, an old BMW, based on the year, the model year. And the data looks like this. And you can see there's a sort of a trend. As the year goes up, the price goes down. But there's a lot of variation. For example, 1995 has 11,999. Another 1995 car, where is it? Like here, is 9988. So it's off by like $3,000, $2,000. So obviously there are other factors that affect the price of a car besides simply the year. And in subsequent chapters, we'll learn about something called multiple regression, linear regression, that tries to use many variables to predict the dependent variable, in this case, price. But in this example, it's called simple linear regression. Let's open the StatCrunch. And the first job is to try to summarize all the data. And we can do that by using the by using stat, regression, and simple linear, meaning that there's only one x variable. There's always only one y variable in the introductory level classes. But in this case, there's only one x, which is the most common case, actually. But again, it's called simple linear. So click on that. We have to pick the x variable. Now, the x variable is often called the independent variable because that's the variable that you're using to make a prediction. It could be any value. And we're expecting that that variable has an impact on the y variable, in this case price, which is called the dependent variable because it depends upon the independent variable, the year. Now, we don't need any of this stuff. This other stuff we'll be using in subsequent chapters. Well, we might be able to use this, the prediction of y. I'll come to that in a minute. But meanwhile, we want a picture. We have that already chosen for us. So there's really nothing basically to do except to pick the year and the price, the x and the y, hit compute. Now, all this stuff we'll be using in subsequent chapters, but we need right now is the intercept and the slope. If you recall, let me go to a picture, the second page of a picture. In this case, this is the data. As the years go on, the price is going down slightly and with a lot of variation. And we believe, and that's an assumption of this chapter, that a straight line can summarize all the data. Now, a straight line, if you recall from high school, can be expressed by y equals mx plus b, where m is the slope and b is the intercept. Except in this chapter, for technical reasons, we call the intercept not b, but b0, and the slope not m, but b1. And the y, actually, the y is the actual data, the dots that you see all over the place. But the y hat, or the estimated y, or the book calls it the fitted y, the theoretical equation that summarizes all the data. So all these millions, it could be millions of dots, can be summarized by just two numbers, the slope and the intercept. And in this case, we know the slope is minus 1053, 0.86, etc. So the first step is to take, they want you to put into, where's the question? Don't need this. We need the intercept is the number that stays by itself. Is that the slope or the intercept? I forgot what I just copied. Yes, that's the intercept. And we're trying to predict the price based on the model year. based on the model year. And the slope is that other number. Actually tells you it's minus 1053.868. 86 is good enough. Copy. And whoops, we lose it again. Oh, it's about keeping these windows straight. That goes here. The slope is a number in front of the X, in this case, model year. And we have now the answer. So check answer. And so far, so good. Now they say explain the meaning of the slope. If you recall from high school, the slope, or the M, or in this case, the B1, actually minus 1,053, represents every time you increase the model year by 1, the price goes down by 1,053. Increase it by 2, it goes down by 2 times 1,053. That's the meaning of a slope. And that means, on average, the model year decreases by, no, it's not that one. Okay, the model year before, meaning that it goes down each year by $1,053. So I'm going to put down, this is the answer. These cars are worth 1,000 less. Every year goes by, a year the price goes down. Now, I did this the first time, made a mistake. I put a minus sign because that would, but actually the less than is already included with the minus. So this is in fact the answer. Check answer. Great. Okay, next, explain the meaning of the intercept. Well, the intercept represents if the model year is 0, which of course makes no sense because there are no cars in the year 0, then the price of the car would be 2,116,000, which may be right if you could find a car that old, but doesn't really make any sense in this context. So the answer is does not make any sense. Sometimes it does, but most of the time it doesn't. Okay, moving on to if a student wanted to sell this, what price would appropriate? 1997. So basically, you plug in for the model year 1997, you multiply 1997 times minus this, add it to this, in this case actually subtract it, and you'll get your answer. But you can use StatCrunch to do that more quickly. 1997. Let's go back to the StatCrunch. You can make a prediction using StatCrunch. So let's do it just for fun. Stat, regression, simple linear. We're using the year to predict price. And we want to make a prediction of 1997. Let's see if that works. Now you can compute. And it's telling us the prediction is $11,597. Let's see if that works. Control C. You can also do it by hand, obviously. Plug in the answer. Find the window. Control V. Check answer. And it worked. Wow. Okay. So we can use StatCrunch to do that. Now, finally, the last verbal question. Prospective buyer has a chance to buy one of 2 cars, same age, everything else. Should you buy with a positive residual or a negative residual? Now, let's go back to the picture to explain residuals. Residual represents the difference between the theory, which is the straight line, and the actual data. So if the actual data is symbolized by Y, and the straight line theory is that summarizes all the data theoretically is Y hat, the residual is Y minus Y hat. So when you have Y minus Y hat is a positive number, that means you're paying more than the theory predicts. If the Y minus the Y hat, if the Y hat is greater than the residual is negative, that means you're getting a bargain. So let's go back to the question with that insight. The car with the negative, of course, it's less than expected. Think about that. And that's done. Okay. I hope that was helpful. And again, anyone with any other questions can certainly send it to me. And leave. Stop sharing. Stop recording. Stop.